Okay, another example for the net electrostatic force between two charges, but in this example we introducing another term, which is finding the direction of the net electrostatic force acting on a specific charge. Now in this example I have a 1000 microcoulomb positively charged is placed at the origin point. Another positive 200 microcoulomb charge placed 2 meters above the origin point, and a negative 300 microcoulomb charge is placed 3 meters to the right of the origin point. What is the magnitude and direction of the net electrostatic force acting on the charge placed at the origin? So our target is the charge at the origin point, or it's the one being colored with purple. This one here, that's our target. And as you can see from the description, this is the one on the right, or on the positive x-axis, the negative 300 microcoulomb. And this one here, it's the one located above the origin point by 2 meters. So just to make things simpler for us, I will call the 1000 microcoulomb as Q1. This one will be Q2, and this one here will be Q3. Now let's start calculating every single force generated by every single charge. Now for the force on 1 because of 2, that will bring us K, Q1, Q2 over the distance 1 square, which means it is 8.9 10 to the power 9 multiplied with the 1000 microcoulomb, and again multiplied with the 200 10 to the power minus 6. All that will be divided on the distance, which is being identified to be 2 meters. That's a 2 meter distance here. So it will be 2 squared. Now, if we do the calculation of this one, that should give us 445 Newton. Now, let's see where is the direction of this electrostatic force between these two charges. Now, Q2 is a positive charge, Q1 also it's a positive charge. That means it's a repulsive electrostatic force between them. This is our target, the 1000. So I'll draw the arrow of the electrostatic force from there. And because it's repulsive, it will be going downward here. That is the force 1, 2, which means this 445 Newton, it can be also labeled with a negative, representing the direction of this force, only this force. It's not that net force yet, to the negative. Now let's keep calculating the other force generated on 1 because of 3. Once again, it's 8.9 10 to the power 9 multiplied with the 1000 10 to the power micro minus 6, and here is 300 10 to the power minus 6, and this all will be divided on the distance between these two charges, which is 3 meters. That will be 3 squared. Now if we're gonna do the math, that will give us 296.6 Newton. Now let's identify the direction of this force. We can see that the Q3 is negative, where Q1 is positive. That means it's going to be an attraction force, and starting from the target, it will be attract to Q3. So that's the force on 1 because of 3. Okay, now we managed to calculate the electrostatic force generated on 1 because of 2, also the electrostatic force generated on 1 because of 3, and once again it is going to be on the positive side. Now, how do I find the total or the net electrostatic force? Okay, let's open another slide to help us. So what I have now, simply it's my Q1, and also I have, that's my F13, and also I have here, that is F12, we said. Now the net electrostatic force will be, here it is, this one. That's what we call the F net. So if I want to calculate the electrostatic total or the net, it will be Fx squared plus Fy squared under square root, or it is the F13 squared plus F12 squared under the square root. Now, if we do the math on this one again, and we just add them up, 445 plus the 296.6, square them of course, and then square root, that will give us 534.78 Newton. That will be the magnitude of the net electrostatic force acting on that 1000 microcoulomb charge located at the origin. Now, to identify the direction of this net electrostatic force, I will say this is theta. That's the angle that net electrostatic force vector making with the x-axis. So it's like here, that's the one here. Now, to do that, we can say, all right, it is tan theta, and it's going to be equal the F12 over F13. Then we can simplify it and say, all right, it's theta tan inverse of not Fy. It's same. It's the same concept. Nothing really changed, because F12, it is also the y side. So it's F12 over F13. And again, when we do the math for the tan inverse, that will give us 56.3 degrees. And it's going to be in quadrant 4. So this is the way to handle a question like this. If you have it set up as a triangle, you simplify it by, first of all, calculating the electrostatic force generated from a certain charge on the target charge, again for the other one. Then you identify the direction of these forces, and if you can draw it on a separate side like what we did here, when we simply just draw the whole action here, we can tell, all right, I have the two main components generating this net electrostatic force. I just follow the rules to calculate it, and I found how much is it. That's the magnitude of the net electrostatic force. Now, to find the direction, we need to find this angle, how much is it? And from the trigonometry's rules, we can follow the tan of this angle to find how much is it. I hope you find this video useful, and thank you for listening.